In this video, you will be presented with a .NET out-of-process memory dump of a .NET process consuming a lot of memory. It is expected that you have already downloaded and opened the appropriate memory dump file in WinDBG, and the MEX extension matching the bitness of the memory dump process is loaded. Analyzing a memory dump in search of the reason for high memory consumption is one of the more challenging scenarios. In many cases, the reason is not discovered using a single command, rather a group of commands. Using the output of numerous debugging commands can guide you to the root of the problem. To start, execute the MEX list threads command. This can take some time, so please be patient. Choose a few of the threads based on highest execution times, for example, threads 6 and 15. Those threads are chosen because they have been executing for some time. Place the threads into context by entering the tilde thread number S, 6S. Execute the CLR stack2 command. You will see on both of those threads, 6 and 15, have non-Microsoft code running on it. Take note of the assembly name and keep it in mind, C# Windows Sierra OOP. That's clue number 1. Memory is mostly stored on what is called the heap. Enter and execute the dump heap stat command to view what objects are consuming memory for this process. Notice that there are 34,100 system.char arrays consuming approximately 2.8 gigabytes of memory. To drill further into what is contained in those arrays, dump the method table. To filter out the 16 KB objects, use the -min parameter, which will potentially reduce the number of objects needing review. It is not always intuitively obvious how to proceed from this point. You will need to do some detective and investigative work. This can take some time, and it is also possible that you will not find anything of value here without a much deeper level of debugging. You do see a lot of objects of different sizes. A few have a size of 71 megabytes. Those that are 71 megabytes should stand out as a place needing attention and more investigation. You would want to perform the following on each of those objects and compare the results. You want to dump the object at that address. This renders the information about the object containing that 71 megabytes of memory. The text next to the context is clue number 2, which may be helpful to a developer in determining where this data may be coming from and where in the code it is referenced. Enter in the following command. This returns the message showing the assembly, class, and method to which the object is linked. Provide the findings from clue number 1, 2, and 3 to the party owning this assembly and have them investigate the code to determine the actions required to prevent it. Finally, but extremely important, is to recognize that memory dumps contain very sensitive information. Take extreme precautions and follow documented procedures for the handling of these files. Remove them from all devices once they are no longer needed.